Today we'll be looking at complex numbers, and a number is said to be complex if it has this form: z equal to x plus iy. So if a number assume this form x plus iy, it's referred to as a complex number. This x is known as the real part, while the y here is the imaginary part. It then means that a complex number has two parts: the real part of the number and the imaginary part of that number. The real part is denoted by REZ, that is the real part of this complex number, equal to x, while the imaginary part is denoted by IMZ, equal to y. So while this is the real part, y is the imaginary part. That is, when you have a number like this, 3 minus 2i, this is a complex number, right? 3 here, which is taking the position of x, is the real part, while 2, occupying the position of y, is the imaginary part. And like any other number, we can perform operations like addition, subtraction, multiplication, and even division of complex numbers. Now, let's look at addition and subtraction of complex numbers. So, addition and subtraction of complex numbers. To add or to subtract complex number, the real parts are added or subtracted together, and then the imaginary parts are also added or subtracted from each other. So when you have two complex numbers and you are asked to add them, you focus on their real parts. Thereafter, you consider their imaginary parts. Example: if we have, for this first one, if we have 5 minus 2i plus 7 plus 4i, for us to add this, the first number you are having here is a complex number. The second one here is also a complex number. For us to add these complex numbers, we are going to focus on the real parts, thereafter their imaginary part. We are going to add the real part and then add their imaginary parts. So the first thing is, we come with the real parts, 5 plus 7, that's the real part. Then for the imaginary part, we are going to have plus minus 2i plus 4i. That's equal to 5 plus 7 is 12, plus minus 2i plus 4i is equal to 2i. So we are going to have 2i as the sum of minus 2i and plus 4i. So that the addition of these complex numbers, 5 minus 2i plus 7 plus 4i, is equal to 12 plus 2i. The second example here, for the second example, we have 5 minus 3i minus 4 plus 6i, right? For this second example, we are dealing with subtraction of complex numbers. And the same rule applies for subtraction of complex numbers. We are going to subtract real part from real part and imaginary part from imaginary part. That is, we are going to have 5 minus 4. So we have 5 minus 4. Then we'll have minus 3i minus 6i. So we will have minus 3i minus 6i. So 5 minus 4, it's equal to 1. Then minus 3i minus 6i is equal to minus 9i. So the difference between these two complex numbers is equal to 1 minus 9i. So that's all about addition and subtraction of complex numbers. We can as well perform multiplication and division of complex numbers. However, one thing that is peculiar to the multiplication of complex number is that we need to take note of I square. And I square is always equal to minus 1. That is, when dealing with multiplication of complex numbers, a time will come where we'll have need to multiply I times I. That is I square. And that value is equal to minus 1. So let's take note of this as we multiply complex numbers. The first example here under multiplication, we have 2 plus 3i multiplied by 5 minus I. Right? So in multiplying these two complex numbers, we are going to pick 2 and multiply by everything we have inside this bracket. Then we also pick 3i and multiply it by everything we have inside this bracket. What that means is we have 2 into 5 minus I. Then we have plus multiplying everything here. Also we have 5 minus I. So what we have here is 2 multiplied by 5 minus I plus 3i. 3i, that's this 3i multiplied by 5 minus I. So expounding this, we are going to have 2 multiplying 5 to give us 10. 2 multiplied by minus I will give us minus 2i. Then we have plus 3i times 5 is going to be 15i. Then we have plus times minus here, giving us minus 3i times I is going to be 3i squared. Right? And that's equal to 10 minus 2i plus 15i is equal to plus 13i. 13i. Then minus, remember that we said I square is equal to minus 1. That's a rule in complex number. I square is equal to minus 1. So if we have 3i square here, it means minus 3 into minus 1. Because the I square is equal to minus 1. Right? So that we have 10 plus 13i Minus 3 times minus 1 will give us plus 3. So that we'll finally have 10 plus 3 giving us 13 for the real part. And then we have 13i for the imaginary part. So this is the multiplication or the product of 2 plus 3i and 5 minus I. The product between these two complex numbers is 13 plus 13i. The second example we have here is 2 plus 4i multiplying 2 minus 4i. So when we have these two complex numbers multiplying themselves, what will be the result? The same way we attempted the example above, we are going to have plus 2 multiplying everything here, then plus 4i multiplying everything inside this bracket. So we are going to have 2 into 2 minus 4i plus 4i into 2 minus 4i. Right? And this is equal to 2 multiply 2, we have 4. 2 multiply minus 4i, we are going to have minus 8i. Then we come to this place, plus 4i times 2, we are going to have plus 8i. Then plus times minus, we are going to have minus. 4i times 4i, we are going to have 16i squared. Coming to this next step, we have 4 minus 8i, we go with plus 8i. And we are left with minus 16. Remember that I squared is equal to minus 1. So we are going to have minus 1 in place of I squared here. And in next step, we have 4 minus 16 times minus 1 is plus 16. And 4 plus 16 is equal to 20. So 20 is the answer for the product of 2 plus 4i and 2 minus 4i. One thing for us to note here is the fact that the product of this complex number and this complex number is a real number. That is, the product is real. And that is because of the form of this complex number. This is because of plus or minus 4i. You have positive 4i in the first complex number and you have negative 4i in the second complex number. That is why their multiplication gives us a real product. If we said plus or minus iy and we said the product will be a real value, we are saying that x plus iy multiplied by x minus iy will give us a real product. That is because I have positive iy here, that is the imaginary part, in one of the complex numbers and negative iy in this other one. So expanding this bracket, you are going to have x into x minus iy plus iy multiplying x minus iy. So opening this, we are going to have x times x giving us x squared, right? Minus x times iy will give us x, y, I. Then we move to this second part, plus iy multiplying x will give us x, y, I. Then lastly, we have plus times minus giving us minus. Iy multiplied by iy, we are going to have y squared, I squared. So when you look at this is negative xyi, this is positive xyi. So these two will cancel out, and you are left with x squared minus y squared, I squared. But remember that I squared is equal to minus 1. So we are going to have x squared minus y squared into minus 1. That is, you will have x squared plus y squared, because minus times minus will give us plus, y squared times 1 will give us y squared. So the product of this kind of complex number will always give us a real product. Next is the division of complex numbers. It's worth noting that the division of complex numbers cannot be done directly, just like we've been doing multiplication, addition, and subtraction of complex number. That is because the denominator is made up of two independent terms. If you are dividing one complex number by another complex number, remember that we said a complex number has two parts, the real part and the imaginary part. So if you are dividing a number and then in the denominator you have two independent terms, where one, for instance, you have a plus b in the denominator. Those are two independent terms, right? So because of that, you cannot divide complex numbers directly. And for us to solve that problem is to use a process known as rationalization of the denominator numbers. That is, we are going to do a conjugate of that complex number. For instance, if you have 3 plus 9i, right, divided by 5 minus 2i. If this is the complex number we have, dividing another complex number, what we will have to do in order to attend to this denominator is to rationalize this denominator. And rationalizing this denominator, we are going to use the conjugate of this. That is, we are going to have 3 plus 9i divided by 5 minus 2i multiplied by, we are going to multiply this by the conjugate of this, that is 5 plus 2i, and then divide also by that same conjugate, 5 plus 2i, right? So we just multiplied both the numerator and the denominator by the conjugate of this denominator. That is how to rationalize numbers. This same method applies when we are rationalizing salt. That is, we have this in rationalization of salt. The idea there is we just finish multiplication, where we said when you have plus or minus the imaginary part, as we do have here, you are going to have a real product. So the idea while we are rationalizing the denominator when it comes to the division of complex number is so that we can have a real product in the denominator. It is from that point that we can divide, right? Until we have a single term in the denominator, we cannot divide complex numbers. So what we have here, look at the denominator. We have 5 minus 2i multiplying 5 plus 2i. With this now, you are going to have plus or minus 2i, which is the imaginary part. Because of that, by the time you open this bracket, you are going to have a real product in the denominator. Right? You can use this method for any other question, no matter how it is framed. Now, here we have 5 minus 2i. If it is positive here, it means in the process of rationalizing, you are going to use a negative value. That is how conjugates are gotten. So now let's open these brackets up to know what 3 plus 9i divided by 5 minus 2i will be. We are going to have 3 multiplied by everything here. That is 3 into 5 plus 2i. Then we will have 9i multiplying everything here plus 9i multiplying 5 plus 2i. All divided by the same thing in the denominator. We are going to have 5 multiplying 5 plus 2i. Then we'll have minus 2i multiplying 5 plus 2i. So from this, we are going to have 3 times 5 giving us 15. 3 times 2i giving us 6i. 9i times 5, we will have 45i. 9i times 2i, that will be 18i squared. All divided by 5 times 5, we will have 25. 5 times 2i, we are going to have 10i. Then minus 2i times 5, we are going to have minus 10i. Minus 2i times plus 2i, we are going to have minus 4i squared. And that's equal to, we have 15 plus 6i plus 45i is equal to 51i. Plus 18, remember I square is equal to minus 1. Right? So we are going to divide this by 25. Positive 10i will go with negative 10i, and you are left with minus 4i squared. And this is equal to 15 plus 51i minus plus 18 times minus 1 will give us minus 18. Then we'll divide this by 25 minus 4. I square is equal to minus 1. Right? So that we have 15 minus 18, that will be minus 3. So we'll have minus 3 plus 51i divided by 25 plus, that's minus 4 times minus 1 will give us plus 4. So that in this denominator, we are now having only real number. Right? So we have here in the numerator minus 3 plus 51i over 29. And this is equal to minus 3 over 29 plus 51i over 29.